Welcome to the topic potentiometric electrodes. As in our previous lecture, we saw what is potentiometry and how it works, what is the principle behind it, how it works, how a potentiometer works, and how endpoint is to be determined or analytical concentration is to be determined in a potentiometric technique. Now we will study about the construction of a potentiometric cell, what are the parts, what are the parts involved in it, what are the electrodes involved in it, and how can we determine the electrode potential of a potentiometric cell, and what are the basic parts and their working. Components of a potentiometric cell. First of all, we should study about the components of a potentiometric cell. The components of a potentiometric cell, as I told you earlier in my previous lecture, the two important components of a potentiometric cell is its electrodes, the indicator electrode as well as the reference electrode. The indicator electrode is the electrode which is directly related to the analytical concentration. It changes the concentration, it changes the potential over the change in concentration of the analyte, whereas the reference electrode remains stable, remains insensitive to the concentration of analytical solution or the test solution. Now we will study the construction or instrumentation of a potentiometric cell in deep. There are basic 5 parts of a components of a potentiometric cell, or a potentiometric cell comprises of a 5 parts of 5 components. First one is the reference electrode, then salt bridge. What is the salt bridge? We will study in our coming slides. What do you mean by a salt bridge? Salt bridge is a let me give you introduction of salt bridge. Salt bridge is a part or component of a potentiometric cell which connects between the two electrolytic solution, anodic solution or cathodic solution. Then third one is our analytical solution. What is the analytical solution? The test solution or the solution of analyte which is to be determined or the concentration of which is to be determined. जिस analyte का हमें पता करना है उसका कोई भी electrolytic solution किसी भी फॉर्म में बस electrolytic solution होना चाहिए. electrolytic क्यों? ताकि वो अच्छे से आयन्स के फॉर्म में टूट सके. What is electrolytic solution? Electrolytic solution is a solution in which the salt is a very good electrolyte which can diffuse into its ion very easily when dissolved in a solvent. तो दैट इज इलेक्ट्रोलाइट. तो इलेक्ट्रोलाइटिक सोल्यूशन होना मैंडेटरी रिक्वायरमेंट है, मतलब उसकी सॉल्युबिलिटी बहुत अच्छी होनी चाहिए. इट शुड ईजिली ब्रेक डाउन इनटू इट्स आयन. अगर इलेक्ट्रोलाइटिक सोल्यूशन नहीं होगा तो क्या प्रॉब्लम होगी? आयन्स बनेंगी नहीं, इट विल नॉट डिसोशिएट इनटू इट्स आयन्स, पॉजिटिव आयन एज वेल एज नेगेटिव आयन, जिसके वजह से आपको आयन्स की कंसंट्रेशन या एनालाइट की कंसंट्रेशन पता करने में मुश्किल होगी. इट विल बी रियली टफ टू डिटरमाइन द एनालिटिकल कंसंट्रेशन इफ आयन्स डज नॉट गेट जनरेटेड वेल इन अ इलेक्ट्रोलाइटिक सोल्यूशन. तो एनालिटिकल सोल्यूशन शुड बी अ एनालिटिकल electrolytic solution in which for which the metal ions analytical ions are to be determined or the concentration of analyte which is to be determined. अच्छा उसका एनालिटिकल सोल्यूशन होना चाहिए या जो इलेक्ट्रोलाइटिक सोल्यूशन होना चाहिए ताकि उसकी जो कंसंट्रेशन पता कर सकें हम बिल्कुल एक्यूरेटली और बिल्कुल प्रिसाइसली पता कर सकें विदाउट एनी एरर. देन next come indicator electrode, which is the most important part of the component of the potentiometric cell is our indicator electrode. Indicator electrode, as I told you in my previous lecture, is the electrode which determines the concentration of analyte because it changes its potential over the titration as the changes of analytical ion takes place. जैसे जैसे एनालिटिकल आयन की कंसंट्रेशन चेंज होती जाती है वैसे वैसे इंडिकेटर इलेक्ट्रोड अपना इलेक्ट्रोड पोटेंशियल चेंज करेगा, जो कि आप एक वोल्टामीटर से मेज़र करेंगे और उस इलेक्ट्रोड पोटेंशियल को जो कि आपको ई सेल के फॉर्म में इलेक्ट्रोड पोटेंशियल ऑफ अ पोटेंशियोमेट्रिक सेल के फॉर्म में पता चलेगा, उसको आप डायरेक्टली कोरिलेट करेंगे एनालिटिकल कंसंट्रेशन से और द कंसंट्रेशन ऑफ एनालाइट विच इज़ टू बी डिटरमाइंड. Then the another important component, another important part of the cell is galvanometer. Exactly, galvanometer or the voltmeter which determines the voltage difference, which determines the electrode potential. Electrode potential determine करना ही तो मेन है. इलेक्ट्रोड पोटेंशियल अगर अच्छा डिटरमाइन नहीं होगा, सही डिटरमाइन नहीं होगा, तो आपके एनालिटिकल कंसंट्रेशन भी सही पता नहीं चलेगी. तो द मोस्ट इंपॉर्टेंट पार्ट ऑफ दिस सेल इज ऑल्सो galvanometer or a voltmeter. तो galvanometer, indicator electrode, analytical solution, salt bridge and a reference electrode. ये 5 component, ये 5 components are a components of a potentiometric cell which are important components. I have depicted them in a equation form as you can see very well. RE, okay, RE, okay, followed by this SB, followed by A, followed by IE, and this all are connected to a voltmeter. This is the voltmeter or galvanometer. It determines what? It determines electrode potential, ठीक है, which is to be determined. और ये इलेक्ट्रोड पोटेंशियल क्या बताता है? कंसंट्रेशन ऑफ एनालाइट, ओके, कंसंट्रेशन ऑफ एनालाइट. तो in this way we studied, this is the RE means reference electrode, okay, then this is SB means salt bridge. Salt bridge is a connection which provides the connection between two electrolytic solutions, okay, nordic solution and cathodic solution, I told you earlier. Then this is A, what is A? Analytical solution or test solution. This is the test solution or analyte whose concentration is to be determined, and this is IE which is indicator electrode, okay, which is indicator electrode which will show electrode potential all over the titration. It shows a electrode potential change all over the titration proceeds, which is directly related to the concentration of analyte which is to be determined. Then this is a potentiometric cell, you can see very well. This is the reference electrode and this is a galvanometer, okay, to measure the voltage difference, and this is a indicator electrode. The reference electrode is that part of a cell, part of potentiometric cell which remains constant throughout the process, and indicator electrode is that part of the cell as it is depicted in diagram also. It is that part of the cell which contains the solution we are interested in, that means sample solution, the analytical sample. The sample or analyte which is to be determined is the indicator electrode. There are two parts of it, indicator electrode, reference electrode, which are connected through a voltmeter. It will determine the voltage or electrode potential, right. Then moving ahead our next slides. Then what is the difference? Now we will study in elaborate about indicator electrode and reference electrode. What is the difference between indicator electrode and reference electrode? The basic difference which we all know is indicator electrode changes its electrode potential over the change in the analytical concentration or concentration of analyte, but the reference electrode remains stable. It is insensitive to the change in analytical concentration, whereas indicator electrode changes its electrode potential as the concentration of analyte changes. The main basic difference is that between the reference electrode and indicator electrode. We can denote the indicator electrode as IE and reference electrode as RE, as we all came to know in our previous slide. In last slide I told you indicator electrode is denoted by IE and reference electrode is denoted by RE. The key difference between the indicator electrode and reference electrode is that the indicator electrode responds very well to the changes in the concentration of analyte, to the changes or the whatever the activity takes place inside the solution in between the test solution, analyte or the electrode. All the reactions are being noted down by the indicator electrode in form of fluctuation or change in electrode potential or voltage, whereas reference electrode does not respond to it at all. Okay, it is very insensitive to the, it is very stable, it is very insensitive to the changes in electrode potential of the analytical solution or test solution. So, that is its response is very stable, as we can see onto our slide also. The last line, it is written there, the response of a reference electrode is stable, whereas the indicator electrode response changes very frequently all over the titration, and this is the main thing which we have to note down. The potential change across the titration with the change in the concentration of analyte. This is the gist, this is the summary, this is the main core of the entire potentiometric process. Furthermore, the electrode potential of indicator electrode is changeable, but for reference electrode it is not at all changeable. It is a reference value which is well known, which is stable, which is insensitive, which is well known also. It is a reference values. For example, when we determine the electrode potential or determine the pH of any solution with reference to hydrogen, we consider hydrogen as a reference value ना, as a reference. Okay, then reference का जो हमें जो हाइड्रोजन है उसका हमें जो pH है वो हमें पहले से डिटरमाइन रहता है, वेल नोन रहता है ना, वो रेफरेंस की तरह कोई चीज़ वर्क करती है तो वो स्टेबल होती है, वेल नोन होती है. सेम उसी प्रकार से उसी तरीके से सिमिलर एज ऑफ रेफरेंस इलेक्ट्रोड का जो इलेक्ट्रोड पोटेंशियल है दैट इज़ वेल नोन, दैट इज़ प्री डिटरमाइंड, दैट इज़ स्टेबल एंड दैट इज़ इनसेंसिटिव टू द चेंजेस in the entire titration or the changes in the analytical solution or in the concentration of analyte, we can say. So, this is another difference between indicator electrode and reference electrode. Some examples for indicator electrode includes glass electrode and metal ion indicator electrode or metal ion membrane indicator electrode, we can say. While examples of reference electrode include saturated calomel electrode, silver chloride electrode and standard hydrogen electrode and pH electrode. Then we shall study in deep about reference electrode and its type. Reference electrode is an electrode which has the half cell potential which is known, constant and completely irreversible, completely insensitive to the composition of analytical solution or analyte which is under study. तो क्या होता है रेफरेंस इलेक्ट्रोड? रेफरेंस इलेक्ट्रोड इज एन इलेक्ट्रोड विच शोज अ स्टेबल, इनसेंसिटिव एंड कंप्लीटली insensitive response which is overall stable all through the process when it is being dipped up in the solution under study or the sample under study. It works very well in conjunction with the indicator electrode, and indicator electrode is the electrode which is also called as working electrode. बिकॉज उसको वर्किंग इलेक्ट्रोड क्यों कहते हैं? क्योंकि हमारा सारा काम वही कर रहा है. वर्किंग इलेक्ट्रोड और इंडिकेटर इलेक्ट्रोड्स विच डिटरमाइन द पोटेंशियल डिफरेंस अक्रॉस द पोटेंशियोमीटर as the titration proceeds or as the analytical solution concentration changes or analytical ion changes their concentration while the reaction proceeds. In conjunction with the reference electrode, the indicator or working electrode who responds depends upon the analytical concentration is being noted out. Then what are the properties, what are the characteristics an ideal reference electrode should show? An ideal reference electrode should have. The ideal reference electrode should be capable to maintain a half cell known potential. एक half cell reaction वो बनाएगा, but उसका जो potential होगा, जो electrode potential होगा, that will be not fluctuating at all, that will be predetermined, that will be known. Okay, that will work as a known. ठीक है, हम हमेशा टाइट्रेशन में हमेशा से यही टेक्निक यूज़ करते हैं कि वन सोल्यूशन इज़ द नोन वन एंड अनदर इज़ द अननोन वन. तो यहाँ पे जो हमारा रेफरेंस इलेक्ट्रोड है दैट हैज़ ए नोन इलेक्ट्रोड पोटेंशियल. ओके, एंड द अनदर वन इंडिकेटर इलेक्ट्रोड जो है उसका पोटेंशियल हमें अननोन है, विच चेंजेस थ्रू आउट द प्रोसेस एंड विच इज़ टू बी डिटरमाइंड एंड विच इज़ डायरेक्टली रिलेटेड टू द एनालिटिकल कंसंट्रेशन, और उससे हमें एनालिटिकल कंसंट्रेशन का पता चलता है. Then another ideal characteristic of reference electrode is that it is reversible. The reaction which it shows is reversible and it definitely follows Nernst equation. Nernst equation, what is that? I told you earlier in my previous lecture what is Nernst equation, which calculates the electrode potential, and which changes its electrode potential or shows a potential difference according to the changes in concentration of analyte or changes in concentration of ions which are to be determined. Another ideal characteristic of reference electrode is it is insensitive. This is very important condition. It should be insensitive or stable to the analytic concentration or concentration of analyte. Then next important ideal characteristic of reference electrode is it exhibits a potential that is constant with time. आपको मैंने बताया कि इसकी जो कैरेक्टरिस्टिक का सबसे इम्पॉर्टेंट कैरेक्टरिस्टिक ये है कि ये बहुत स्टेबल होता है थ्रू आउट द टाइट्रेशन, थ्रू आउट द प्रोसेस. इट डजंट चेंजेस इट्स इलेक्ट्रोड पोटेंशियल विद टाइम. इट इज़ क्वाइट इनसेंसिटिव टू द एनालिटिकल कंसंट्रेशन. जब इनसेंसिटिव होगा तो इट्स ऑब्वियस कि वो स्टेबल रहेगा थ्रू आउट द प्रोसेस, थ्रू आउट द टाइट्रेशन. उसका कोई भी इलेक्ट्रोड पोटेंशियल में फ्लक्चुएशन नहीं होगा, कोई चेंज नहीं होगा, चाहे आप कितना भी एनालिटिकल कंसंट्रेशन चेंज करते जाएं. तो दिस इज इट एग्जिबिट्स अ पोटेंशियल विच रिमेन्स कांस्टेंट, विच रिमेन्स अ रेफरेंस वैल्यू throughout the titration, throughout the process. Then it returns to the original potential after being subjected to small currents. Okay, if that is another important condition, for characteristic for that if a small fluctuation takes place during the titration, it returns to its original value after showing a small fluctuation of currents. Then exhibit little hysteresis with temperature cycling. We all know what is hysteresis. Hysteresis is the motion or kinetic movement inside a solution with the change in temperature. तो hysteresis के लिए भी ये stable रहेगा. It doesn't changes its concentration or changes its electrode potential. It doesn't changes its flow of electrons, flow of ions with the hysteresis cycle or temperature difference. Then these are the types of reference electrodes. First reference electrode is our standard hydrogen electrode. We can see here it comprises of, it is an ultimate hydrogen electrode, standard hydrogen electrode. Okay, we can see here the platinum black electrode, platinum black plate which works as electrode, which is dipped in the solution of HCl. Then next one is silver chloride electrode. Here the electrode works as a simple wire of silver which is being dipped up in a solution of silver chloride. Another common reference electrode, you can see in the diagram, this is the wire of silver and it is being dipped up in the solution of AgCl. Then the third type of reference electrode is standard calomel electrode, okay, or mercury electrode. It forms a mercury chloride electrode in which this is the mercury fiber which is being dipped up in a solution of silver chloride, another dipped up in a solution of KCl. This is standard calomel electrode. So there are basically three types of electrode, reference electrode. We can see standard hydrogen electrode, She or SHE, then silver chloride electrode or silver electrode. The next one is calomel electrode or standard calomel electrode, SCE. Okay. So these were the types of reference electrode. We can see easily in the diagram. Okay. These were the ideal characteristic a reference electrode should see, should depict. It should have these characteristics. So altogether now we can summarize what are the types of potentiometric electrodes. We can easily summarize. Basically there are two types of potentiometric electrodes, reference electrode and indicator electrode. Reference electrode should be sensitive, should be stable, should be insensitive, towards the change in analytical concentration. Its potential should be known. It works as a reference for the other electrode, and it shows a reaction which is irreversible. It should totally follow Nernst equation, okay, and it does not show hysteresis at all, or if it shows, it should exhibit a little bit of hysteresis. That means that ionic concentration does not changes even upon change in temperature. Okay. So, these were the conditions, or these were the characteristics of ideal reference electrodes. Its potential does not changes and remains constant with time. It should be stable, it should be insensitive, okay, and its value should be known, and it works as a reference electrode, reference value for the indicator electrode. Then what are the basic construction of potentiometric methods? We all saw. Then what are the components of potentiometric cell? Potentiometric cell के क्या क्या components? We all studied about it. There are basic 5 components of it: reference electrode, salt bridge, analytical solution, indicator electrode, and a galvanometer. So then for reference electrode, we studied its type. There are 3 basic types: standard calomel electrode, standard hydrogen electrode, and silver chloride electrode. Then salt bridge, okay, that is the connector between the 2 analytical solution, 2 electrolytic solution, or 2 electrodes in which solutions are being dipped up. What are the functions of salt bridge? We will study in our coming slides in our next lecture. Then analytical solution or test solution, in which it is the test solution in which your electrodes are being dipped, or the solution of analyte which is to be determined. ठीक है, इसका concentration हमें पता करना है. Then indicator electrode is the electrode which shows changes in potential. This is the main electrode which shows changes in potential across the titration, all over during the titration, changes in electrode potential, which directly relates to the changes in concentration of analyte or analyte which is to be determined. Then last component, last but not the least, it is the main component which determines the electrode potential. Okay, this is the electrode potential, and these are the components in total as we all studied. So, that was all about potentiometric cell. Let me summarize it. Potentiometric cell comprises of 5 things, 5 components, okay, reference electrode, salt bridge, analytical electrode, analytical solution, indicator electrode, and galvanometer. All the functions are being shown up there. Then this is the diagram of a potentiometric method, potentiometric cell. Then what is the key difference between indicator electrode, and what is that? What is the main difference between indicator electrode and a reference electrode? Indicator electrode changes over the entire process, but reference electrode remains stable, remains insensitive. It has a known electrode potential which is predetermined to us. Okay. It does not changes its electrode potential all over the process. In fact, it does not changes its electrode potential with temperature changes also. Okay. So, that works as a reference for only working electrode or indicator electrode. That works as a reference only, right. Then this is the difference between indicator electrode and reference electrode. Indicator electrode responds well to the activity or concentration of analyte, or the analytic concentration, or the number of ions or number of analytes, which concentration of analyte which is to be determined. Also, the reference electrode potential is predetermined, is constant and insensitive, and is well known. but indicator electrode, the electrode potential has to be determined, and that determined electrode potential directly reflects or is directly related to the concentration of analyte. Okay. So, here we can see that this is the another main difference between the indicator electrode and reference electrode. Then some of the examples of reference electrode included. Let us go through it. Standard calomel electrode, AgCl means silver chloride electrode, standard hydrogen electrode. Okay. These were the types of reference electrode, and the types of indicator electrode include glass membrane electrode or glass electrodes and metal ion indicator electrode or metal ion membrane electrodes. Then what was a reference electrode? Let us summarize it. A reference electrode is an electrode that has half cell potential. Its half cell potential, which is very constant, which is insensitive, completely insensitive throughout the process to the entire analytical solution and to the composition of the solution which is under study, which is under test. Okay. That is the reference electrode. Plus it has a well known standard reference value. It has a standard reference value, standard reference electrode potential, which is predetermined or well known or a known value, which is known to a analyst. Then it works. How does it work? It works with the conjunction of or in connection to indicator electrode or working electrode. What is that? Indicator electrode or working electrode, whose response or whose electrode potential changes directly with the change in analytical concentration. So, that is all about reference electrode. And how does it work? It works with the relation to analytical, relation to changes in electrode potential of indicator electrode. Okay. It itself does not work if indicator electrode is not placed over there. Indicator electrode will not work totally if reference electrode is not over there. That means both are complementary to each other. Indicator electrode as well as reference electrode works together. Okay. Works both hand in hand. Okay. Reference electrode will need indicator electrode for the values to be shown, and indicator electrode will definitely need reference electrode for the concentration of indicator, for the concentration of the analytical solution to be determined. Then ideal reference electrodes, we all studied what were the properties. It should maintain a proper half cell reaction. Okay. The reaction should be irreversible and should be determined easily with Nernst equation, or it should ideally follow Nernst equation. It should be quite insensitive to the titration, to the change in concentration of analyte under study or the test solution. Okay. It should be stable throughout the titration or throughout the process. It should exhibit a potential, electrode potential. अब electrode है तो electrode potential तो बताएगा ही. It should exhibit an electrode potential which is constant throughout the process or constant with time, as well as temperature also. That I told you, already told you, that is already there at in the last point, कि exhibits little difference in electrode or exhibits बिल्कुल least difference in electrode potential with hysteresis also. Okay. Temperature change के भी कोई impact आपके reference electrode पे नहीं पड़ना चाहिए. It returns, suppose current fluctuation से थोड़े बहुत change होते हैं, then it should return to the original electrode potential after being subjected to small fluctuation in the current. These were the types: standard hydrogen electrode, silver chloride electrode, then standard calomel electrode. Then this is the reference. If you people want to go through it, you can refer it.